Now we're going to look at conditional statements and how to rewrite them in if-then form, the converse, the inverse, and the contrapositive. We're also going to look at whether these statements are true or false. Before we do any of this, I kind of want to give an overview of converse, inverse, and contrapositive. So I'm going to get out a separate paper here. And if we're talking about a conditional statement, I'm just going to do a shortened version of this that's often used in a lot of mathematics. I'm going to write it as P and then an arrow and then a Q, where P is our hypothesis and Q is our conclusion. So it would be if P then Q, or in this case literally it means P implies Q. If this is true, then the converse, let's do that next. The converse is found by simply switching the Q and the P. So we would write Q implies P, or we would write if Q, then P. So all we're doing is switching those around. The next statement would be the inverse. And I'm going to write the inverse over here. And the inverse is found by doing the opposite of P and the opposite of Q, what we call a negation. So I'm going to put a little tilde here like thing and put a P, which means not P here, and that implies not Q. And finally, we have our contrapositive. Make sure you take notes on this. For the contrapositive, what we actually do is we say sort of a combination of a converse and an inverse here. So not only are we going to switch it, but we're going to negate both. So we would write not Q implies not P, or if the opposite of Q, then the opposite of P. So I'll show examples of all this and relate it to the P and the Q and all of that. So for this first example, we've got the statement, guitar players are musicians. So we want to write it in if-then form, converse, inverse, and contrapositive. So if we do this, the if-then form, remember our hypothesis is guitar players, our conclusion is musicians. So to write this as an if-then form, we would write if you are a guitar player, then you are a musician. My P is here. My Q, I'm going to double underline it. My Q is there. So it's P implies Q. And if you were a guitar player, then you are a musician. That is true, because a guitar is a type of musical instrument, so that would make you a musician. So that one would be true. The next statement is the converse. Now, if you notice between the if-then statement and the converse, all we've done is switched the Q. The Q is now here, and the P is now at the end. So again, remember, before we had P and then Q, and now we have Q then P. And if we look, if you are a musician, then you are a guitar player. This is false, because you can be a musician but not be a guitar player. You could be a piano player. Okay? You could play any other musical instrument and still be a musician. So this is a false statement. And we're going to now look at the inverse. For the inverse, it says if you are not a guitar player, then you are not a musician. So let's go back one. This says if you are a guitar player, then you are a musician. So this is P implies Q, and this is the opposite of P. So this is not P, and this is not Q. So if this, then that. But it's the opposite of what we did when we did the what's it called? The if-then statement. It's just the negation of both of those. So if you are not a guitar player, then you are not a musician. This one is also false. And we're going to find a pattern with this as well. And we'll go back to that in just a minute. So that's false, because just because you don't play the guitar doesn't mean you can't be a musician. And finally, remember this one right here is not Q, implies not P. So this is not Q, and this is not P. And in this case, this is true. If you are not a musician, then you don't play guitar as well. So that would be true. And what we're going to find in general, I'm going to write this down as well. Let me get a piece of paper. If we have P implies Q, Q implies P, not P implies not Q, and not Q implies not P. So this is our if-then. This is our converse. Inverse and contrapositive. Ooh, squeeze it in. Now, these two right here are connected. If the if-then statement is true, then the contrapositive is true. If the if-then statement is false, then the contrapositive is false. Similarly, these two are connected as well. If the converse is true, the inverse is true. If the converse is false, the inverse is false as well. And if we know that the if-then statement is true and the converse is true, then all four of them will be true. And we'll talk about that more in just a little bit. I'm going to show you a couple more examples. Just go through those a little bit quicker. We have the statement, if a dog is a Great Dane, then it is large. This is our conditional statement, and that is true. So the converse, we switch the large. And remember, there was no dog here, so we have to say, if a dog is large, then it is a Great Dane. That's false, because we could have a dog that is large but not a Great Dane. Then for the inverse, if a dog is not a Great Dane, then it is not large. That's also false, because we could have a dog that's not a Great Dane and it could still be large. And finally, the contrapositive, if a dog is not large, then it is not a Great Dane. That is true, because if it's a small dog, it's not going to be a Great Dane. I know that's a lot to write down. Make sure you pause the video if you need to. For this next one, we have if a polygon is equilateral, then the polygon is regular. This is a false statement, because we could have an equilateral polygon that's not equiangular, and then it wouldn't be regular. So this doesn't guarantee it's regular. Therefore, when we do our converse, if a polygon is regular, then it is equilateral, yes, because if it's regular, it's equilateral and equiangular. So that makes it true. The inverse should be true as well. If a polygon is not equilateral, then it is not regular, yes. If it's not equilateral, that's part of being regular, so that's true. And finally, the contrapositive, if a polygon is not regular, then it is not equilateral. That's false, because we could have an irregular polygon that's still equilateral. And that's it for this one. Thank you.